Hello everyone, thanks for participating. As you can see, we were getting equal years for these two algorithms, so we delay this video and right now you can see as we are getting maximum votes for this optimizer. So in next video we will cover this optimizer step by step using different examples, and in this video we will understand what is Nash equilibrium in game theory. We will try to understand this using different examples and also cover its application, challenges, and benefits. Now let's start it. So first we will start with what is Nash equilibrium. This term comes from the mathematician who introduced the concept that in many competitive games there is often at least one stable state where no player can do better by changing their own strategy as long as the other players stick to their strategies. And this stable state is called Nash equilibrium. It is named after him to honor his work in game theory. Nash equilibrium happens when each player knows what the other players are doing and no one can improve their payoff by changing their own strategy. So what is Nash equilibrium in game theory? It is a concept that describes a situation where no player can benefit by changing their strategy while the other players keep their strategy unchanged. Here you can see this strategic interaction, and this strategic interaction is applied to games where players make decisions that affect each other, and each player's strategy is the best response to the strategies of other players. And at the Nash equilibrium, there is nothing for any player to gain by independently changing their strategy. So we have a situation where no player can benefit by changing only their own strategy while other players keep their strategy unchanged. Now let's try to understand this using a simple example. For example, two kids choosing between playing football or cricket. First case we have if both choose football, both are happy. Second case, if one choose football and the other cricket, they are less happy. Third case, if both choose cricket, they are okay. So if both kids continue playing football because they know it would make them happier, that is Nash equilibrium. So by playing football, both are doing the best without changing their choices. Now second example we have competition between two companies. Suppose we have two competing companies, company A and company B, and they sell similar products. Here each company can set its price either high or low, and their profit depends on the combination of their pricing strategies. Here you can see the payoff matrix. We will consider the profit for company A and company B in dollar millions. So we have two companies, company A and company B, and they can set price either high or low. So we have high price and low price. Now first case we have if both set high price. Here you can see company A set high price and company B it also set high price. Value we have here A10 and B10. It means both companies are making $10 million because they avoid aggressive price competition. Second case, if one company set high price and other company set low price, then the company with low price attract more customers and make $15 million while the high price company loses customer and makes only $3 millions. Here you can see company A set high price, so this company make only $3 millions, and second company it's at low prices, so it is making $15 million. And third case similar we have if company A set low price and company B is setting here high price, then we have value 15 and 3. By setting low price, company B is making $15 million and company B is making $3 million. Fourth case we have when both companies will set low price, they engage in a price war and it will reduce the profit to $5 million each. Now for this example, Nash equilibrium occurs when both companies set low price and it will also reduce their profit. This shows that companies often end up in a price war that represent how competition can lead to suboptimal outcomes for all players. And this example also reflects real world pricing strategies such as price war in airline industries or retail. Here you can see important elements of game. We have players, second we have strategies, third we have payoff. So first core element we have players, that is our participants in the game. Here players are the decision makers in the game. Here you can see example, we have individuals, countries and all. In n player game, we will identify each player numerically. For example, you can see here, suppose we have 10 players. So value we have here, I is equal to 1 to 10. We have player 1, player 2, player 3, up to player 10. And each player decision influence each other, and their decisions collectively influence the outcome. So here, each player's choice of strategy contributes to the overall outcome of the game. Second core element, we have strategies. So here strategy is a plan of action a player decide to follow in the game, and it represents the possible moves available to the player. And mathematically we can write it as SI. You can see this is the set of strategies available to player I, and here we have each player with specific strategy. So each player will choose different strategies. Third, we have payoff, that is the reward or outcomes for players based on their chosen strategy. Here you can see payoff function expressed as UI, and inside we have player strategy S1, S2 up to Sn. Here this represents the strategies chosen by all players, and all players are aware of the rules of the game and other players' logic, and this include both parties' mutual awareness of the strategies, rewards, and reasoning, and some specific information may vary based on timing, visibility, and context of decisions. You can see we have different types of strategies, like we have pure strategy. So first we have pure strategy. So here players select one specific action. For example, always choosing to cooperate in prisoner's dilemma. Now what is prisoner dilemma? This is one of the most well-known example in game theory, representing a situation where two individuals face a conflict between their own interest and cooperation, and game design often encourages selfish behavior from both players, which result in poor outcomes for both, even if cooperation can be helpful for both. So, for example, we have two criminals, A and B, and they are arrested for a crime and imprisoned in two separate cells, and they are investigated separately. So, players we have here two prisoners, A and B. So, we have two players, that is our prisoners, and you can see here they are isolated and they cannot communicate. So players we have two prisoners. Now next we have strategy. So here each player have two strategies, either confess or not confess. So we have two cases, confess and not confess. If they confess, it means they collaborating with the magistrate by sending the other person into it. Second case, not confess, it means both remain silent and refuse to cooperate with the magistrate. Third core element we have payoff, that is the outcome. So payoff is here the outcome depends on the combination of choices. So first choice we have, if both confess, each receives 3 years in prison. If both not confess, then each receive 1 year in prison. Third case, if one confess and other does not, then the confessor goes free and the other receive 4 years in prison. So here you can see the payoff matrix. So we have two players as our prisoners, prisoner A and B, and they have two strategies, either confess and not confess. First case we have both not confess. It means both playing simultaneously decide not to confess. Now both will spend 1 year in jail. Second, you can see here first prisoner not confess and other confess, then the second prisoner will be free and first will be in prison for 4 years. Third case you can see here, first one confess and second does not. So here first one will be free and other for 4 years in the prison. Fourth case, if both confess, both will be in prison for 3 years. Now here what is dominating strategy? So here dominated strategy is one that gives a better outcome for a player regardless of what the other player chooses. So for this example, so we have two prisoner, and if one prisoner is staying quiet, so here other prisoner can confess and get the freedom, because it is better than staying silent and getting 1 year imprisonment. So here confessing leads to freedom, that is better than staying silent. Second case, from these two prisoners, one confess Second prisoner not confessed, he will be sent to prison for 4 years. So here confessing is better option than staying silent. So here you can see confess is the dominant strategy for both players. So Nash equilibrium occurs when neither player can improve their strategy to optimize the outcome. So in this case, if both confess, that is the Nash equilibrium. So if A confess, then B's best response is to confess as well. And if B confess, then A's best response is to confess too. If both confess, then both will be end up with 3 years in prison. So here you can see Nash equilibrium. We have both confess it is not socially optimal because if both stay quiet, then each will get just 1 year in prison. But the fear of disloyalty and specific reward to confess lead them the worst collective decision. Now both will spend 3 years in jail instead of one. Now here you can see different applications of Nash equilibrium in economics and business that is used for pricing strategies. Here companies use Nash equilibrium to predict the outcomes in competitive pricing. Next we have market competition that help in understanding the market behavior. Then we have in politics, they use to analyze the voting behavior and the party strategies in election. Third, we have social science in biology for evolutionary stability. So Nash equilibrium is used in evolutionary biology to study the strategies that survive over generation. Then we have in artificial intelligence for a multi-agent system that helps in designing algorithms with autonomous agents interact with each other using different strategies. For example, we have self-driving cars, robots and all. Then we have different benefits of Nash equilibrium, its predictive power. So that's all about this video. If you have any questions, you can comment below. And thanks for watching this video.